I go by Technomancy on IRC. Got a blog there. I work for Every.com in Seattle doing semantic web things. Cool stuff we're hiring, so you can see me, if you're looking for work. And for my weekly dose of awesome, I go to the illustrious Seattle.rb meetings, which, oh yeah, highly recommended. Consistently ranking #1 across the nation in customer satisfaction, or something like that. So, feedback. Right, this is a talk on how to be a more effective developer, and it really builds a lot on the book, The Pragmatic Programmer by Dave Thomas and Andy Hunt. If you've read that, that's really gets to the meat and the essence of being a good developer. If you haven't read that, now go read it. I won't. Yeah, feedback. I think our sound system's somehow picking up on that. Yeah. So Pragmatic Programmer. Read that book. Read it now. Really, it's so good. If you walk out right now to go buy it, there's a bookstore down the street. I won't feel bad. Very important book. But okay. Yeah. Okay. Thanks. So, how to be a more effective developer by harnessing feedback that you get from your code. This is not about feedback that you get from your customers or clients, but you and your code. So, if you've gone through, I'm gonna talk about a few things that are probably gonna seem obvious or redundant, but that's just because I think by looking at things that we understand really well, we can see patterns and ways that the principles there might be applied to other areas that we might not have thought of immediately. So testing is really good stuff, right? Obvious. Seriously. So if you've been writing software for any amount of time, you've surely gone through this this path, right, where you start out testing everything by hand because you need to know if stuff is working correctly, obviously. So you're clicking through your program and you're just making sure in your head that it's working the way you expect it to and that it's working correctly. And you get that important information, right? And that works. But it's no good. It doesn't scale. Too slow. Doesn't happen often enough because it's too slow. And it's unreliable. You're doing something that a machine should be doing. And recognizing situations like this is half or a good portion of being a good developer. So what do you do about this, right? There's a lot of smart people programming, as you may have noticed, and so they've tackled this problem, obviously, and this is the solution as far as I'm concerned. You have automated testing suites with testing to RSpec. Now I'm gonna use the testing terminology here. If you're doing BDD, that's great. I'm talking about that as well, but. Can I just get a show of hands who uses automated testing or BDD daily? Okay. How many of that is test unit? And how much of that is RSpec? Cool, okay. And how many of you would feel really guilty checking in more than like a page of code to an important project without any sort of testing at all? Good. Okay. Great. So the advantage here you get with automated testing is it happens quickly, right? Right? Well, yeah, if you do it right, it happens quickly. And it happens often, right? Because it's easy. Well, yeah, if you're disciplined, it happens often. And it tells you when stuff breaks, right? Well, yeah, if you cover your bases, it tells you when stuff breaks. So that's great, and that's a huge improvement over manual testing, but still a lot of ifs. So what do we do about this, right? Well, again, we've got our best people working on it. So one improvement on this is autotest. For the three of you in the back who don't know what autotest is, you point at your project, and it watches all the files, and when anything changes, it tries to figure out which are the relevant tests to run, and runs those in the background. But the key is it doesn't require your input, and it'll do it just based on the fact that you saved your code. So you don't have to be disciplined. You don't have to constantly be hitting the rake test command. And it lets you know what you need to know, when you need to know it, and the key is whether you need to know it or not. Because a lot of the time, you're writing your tests, writing your code, whatever, and you make a small change, and you're thinking, this is a tiny change. It's not going to affect anything else. And you're wrong. Because software is really complex, and it's really hard to isolate when a change made in one place is going to be affecting other places. So, but there's still, this tiny little, and this is really a nitpick, because this is a lot better than just running your tests manually, and this is way better than testing by hand, but you're still kind of doing this whole dance between your terminals and your editor. And the more you test, the more you're going to be doing this. And so there's slightly suboptimal stuff going on there. So let's notch it up another level. FlyMake is something that was released with the latest version of Emacs. And this isn't actually test related, but I'm bringing it into there. It was Emacs mode developed for C code that would run your buffer, your text files through the compiler with warnings turned on, and then it would highlight the buffer in the parts where the problems were. Like it knew enough about the output of the C compiler to correlate that and show it to you in the buffer, which is where you need to see it, because that's where you're spending all your time. So that's a real big win there. And this has been ported to Ruby as well, but it just runs it through Ruby-W, so you get Ruby warnings. So it's a big win for situations where the interpreter can tell you that you've screwed up. But so we're not really all about compile time safety. We're about comprehensive tests. This is like the banner that the Rubyists are always waving, right? So this is good, but not quite optimal. TestUnit.l applies the same principles to FlyMake, from FlyMake to testing. It's a Emacs mode that I've written, and it's just kind of an experimentation that I've worked with, but I feel like it takes that feedback loop where you make a change, it trickles through your system, and eventually you find out about it, and it just tightens that to the point where if you tighten it anymore, you're not going to get any further benefits. Right? You get your test results on the fly, and it's the same stuff that you're getting from Autotest, but it's a lot more obvious where the problems are, right? If you see the Autotest output, it's just like the test unit output. It'll tell you, this test method failed, and this is the line number, but you're kind of squinting at the line number, and you're kind of switching back to your editor and doing go to line 82, whatever. Eliminates all that. So you'll see here you have one error, 2 OK tests, and a test with a failure that's doing something ridiculous. Right. So this is just kind of something I've been experimenting with. It's closing the feedback loop, right? Tightening it up. So I'm kind of synthesizing the principles we get here into something that I think is applicable just across the board in your development processes, in your habits and stuff. Number one is you really care about your accuracy, right? That's like the top priority. So you set up tools to measure it because you care about it so much. And then you finish the job by getting notified about it when something goes wrong, when the state of the project changes in a significant way. And right, so you've got here that level of delay, and you'll see as you get over here, it's a diminishing returns kind of thing. Doesn't change that much, but it's still kind of nice. You get you start to take it for granted, and it's super, right? So what about other things we care about? Can we apply these same principles there? And I think the answer is yes. And otherwise, this would be a pretty short talk. So we can, right, right? Most of your problems and your bugs are caused by making a change and not understanding what the side effects of that change are. So if you have a higher awareness of your code, unintended side effects are reduced, and there we go. Yeah, I hate this slide, but I like that last line, so I had to leave it in. Now, I'm kind of a history geek, so I love reading about the early days of computing, about, back in the days that they first realized that, wow, information is a substance. It's not matter. It's not energy. So I've been reading a lot about cybernetics and things in the first half of the century where computers were first being applied to thinking, right? So you have this concept of feedback, and it's pretty central to cybernetics. You have a proportion of the output signal being passed and fed back into the input. Now, this is originally applied to mechanical devices. So the picture you saw in the first slide is the steam governor created by James Watt. It's kind of like the first machine to explicitly harness this feedback principle and become more effective by that. So I kind of see that as a good symbol of what we're doing here. So, right, this is a commonly well-understood principle, but the key is here it's being applied to software, and you're the control system. So, yeah, feedback is you, the output, getting fed back into the input system. Where do we go from here, right? Well, we covered testing. We need to ask, how are we going to apply the feedback principle to as much as we can to get really the full benefit out of it? What do we measure? How do we measure it? And when does that output get fed back into the system? When are you notified of the results of your measurements? And I'm going to answer the first question because it's the easiest first. And yeah, what do we measure? Well, everything we care about gets measured, right? What gets measured gets improved. Simple enough. So what do we care about? Accuracy. Yeah, we've covered this with tests. Tests are a way of measuring your accuracy. So we've identified that, and we've talked about ways in which you can automate the measuring of that metric. But there's actually kind of another way, and that's through syntax highlighting and indentation. You think of those as a really low-level accuracy check on your code, because when you look at your code, you see, maybe you misspelled something. You misspelled class, and you look at your editor, and a class isn't purple, so you have that instant feedback. It's almost subconscious on that level. Class isn't purple, something's wrong, okay, because you're so used to that. And the same with indentation, right, because you have this idea of, well, hopefully your editor does this for you, and hopefully, all your files end with an end statement on column 0, and if that's not the case, something must be wrong, right? So you have that instant feedback. Hopefully it's instant. If it's not, make it instant because it's really helpful. It's interesting to note here that syntax highlighting actually, when it first came about, I think it was in Emacs at least. I think it was version 19, so that was like aeons ago, back when dinosaurs roamed the earth, and it ran on VMS. People introduced this idea, and it was turned off by default because it was just so slow. So this is just something you can appreciate that Moore's law has given us. But I think it doesn't have to stop with that. All forms of accuracy checks are helpful in your face as possible, and the editor is as in your face as possible as far as I'm concerned, because it's where you spend the most time. And if you don't spend the most time in your editor, either you're a UI guy or you need to work on your editor and get it to the point where you can spend more time in it. I've got something at the end of the talk that I'd like to show that shows how this can be better integrated, a tool that I'm working on. But we'll get to that. I just like to build the dramatic tension there. So, yeah. So we're measuring our accuracy, and that's great, right? We're getting a lot of good feedback from that. Our code is improving. We're becoming more effective. But the thing that we don't know so much about is how accurate are our accuracy checks. This is kind of taking the question to the next level. I use the term meta-accuracy. And this is just a way of making sure that we're actually getting value from our accuracy checks. Especially when you're starting out, you don't know a lot about unit testing. You're going to miss a lot of the edge cases that are important, and you're just not going to have a good feel for what the level of testing that you need is going to be. So we automate this because we are pragmatic, and we do that when it's important. The first tool that I'd like to talk about for that is Heckle. It's a tool that it works with your code and your tests together. It runs your tests all the way through. It makes sure they pass. If they don't pass, you've got bigger problems to deal with than meta-accuracy. And then it takes your code in and parses it, and it's got the parse tree there, and it actually just hacks at it and mangles it wildly. Well, not wildly. It makes it one change at a time, and then it runs your tests in between each of those changes. If your tests still pass when your code is broken, then your tests aren't very good, right? Because they didn't realize that stuff broke. So that's kind of the idea behind that. I think that came out of actually last year's RubyConf. So that's a historical note there. So that's a good thing to give you feedback about the value of your tests, how good they are. The other one that a lot of people use is Archive, and this is just a coverage report system. So this will run your tests, and it'll tell you how much of your code was executed, which is, it's valuable information. But the problem here is a lot of people go overboard with it, and they'll look at their test coverage, and it'll be really high, and their tests can still suck because they're not testing the right things. They're not actually testing the edge cases. They're just running through the code blindly. So take it with a grain of salt. The thing that's valuable here is it can tell you if you're totally screwed. It can't tell you if you're in good shape. Right. So when do we care about getting this information back in our face? This is not quite as immediate as our accuracy checks need to be, because with tests, with your accuracy checks using tests, you're constantly going to want that feedback. If you constantly got this feedback in your face, it would not be very interesting because it does not change as often. And it takes a lot longer to generate, too, especially with Heckle, because it has to make a bunch of mutations on your code and run the test again for every mutation it makes. So not the kind of thing you want to be doing all the time. But, you could do it manually, but you've got the same problem there as doing your tests manually, where it's just not going to happen as often. It's not going to happen when it needs to happen because, you're going to get busy, and that's really when you need it the most. So how do you offload this? The real question is just one of frequency, right? How often do you need this information back in your face? And that's a personal thing. I think a good baseline would be to get daily checks in your inbox. But a lot of people, especially if you're just starting out, you're going to want more. If you're working on a really boring portion of the code where it's all pretty straightforward, you might not want as much, and you're just going to start to get annoyed by all these emails in your inbox that aren't giving any value. And so the key here is instead of turning it off and I've got too much to deal with, just decrease the frequency. And that's a good general rule with this kind of thing. So what else do we care about? Maintainability is pretty important, right? This determines how quickly you're going to be able to fix bugs in your software in the future and add new features, things like that. I love this quotation from Martin Fowler. He says, "Any fool can write code that a computer can understand, but good programmers write code that humans can understand." I appreciate that a lot because keeping that in mind leads to code that's easier to maintain. So we have identified the metric we care about, but, problem, right? Um, maintainability is a function of the human mind's ability to understand a piece of code. So how do you measure that automatically? Well, we don't really have very good human mind simulators. We can't just give a software a piece of code and say, how readable is this? So what do you do when you're confronted with a problem that's really difficult like that? You cheat, right? You measure complexity because they're correlated. So the more complex it is, the more difficult it's going to be to maintain. How do you do that? Well, there's another cool tool called Flog that will do this. Once again, loads up your parse tree, and this time it just counts, basically. What's in there? Has a way of counting, just measures assignments, branches, and calls, and those are like the building blocks of any code on a low level. And it's weighted on top of that, so like a call to instance eval is going to increase your complexity score a lot more than a call to puts is, because it's a lot more, it adds a lot more of a maintainability burden. If you see code that uses instance eval, you're going to have to sit there and think really hard about it before you can understand what it's doing. So that's Flog. Pretty cool, but the problem is, what do you do with the output it gives you? Because it's not going to look at your code and say, oh, your code's peachy, or, this is awful. It's not going to give you a 5-star rating. It's going to give you a raw absolute number. So, what do you do when Flog says your code is 800 Flog units of complexity? And the key here is to compare it with something else that provides approximately the same amount of value. So if you've got something that's doing something relatively simple, a piece of code, and it has an improportionately high Flog score, that's a bad sign. You run it over your code, different files in the same projects to see potential places where you could be refactoring. But think about it as value you're getting per feature. So that's Flog. How do you use this information? Well, I like to think the best way to do this would be on a per commit basis, so that you catch the complexity before it makes it into your repository. So other people don't see the nasty mistakes you made, all that complexity you added. You're not embarrassed by it. So on a per commit basis, but this kind of requires you to be a little disciplined. Patch bombs are right out. A patch bomb is when you make a commit that has a bunch of unrelated features in it. If you're not using patch bombs, every commit you make is very focused and does a certain thing, and it's just that, very readable when you're looking over the repository history. With a patch bomb, you'll be modifying 3 classes and changing the way your whole system uses threads, and maybe a whole bunch of other things too. And that's just going to make it hard to measure this kind of thing and make it hard to look back at the history of your repository. All kinds of bad problems happen with patch bombs. Stay away from them. But it does take a lot of discipline. So you can use tools like Git will help with this. But it's just something you need to internalize. So on this per commit basis, you need to think about, what did this code do before I started working on it? And what does it do now that I'm about to check it in? And is that appropriate for the amount of complexity that I'm adding? Because complexity is, in a way, it's inherent. You can't have a new feature added without touching the parse tree, without touching modifying the AST. So some of it's necessary, but how much of it is justified? And you really want to make your code justify itself. So the other thing I want to cover in terms of getting this notification of the complexity scores is, again, like with the testing output, you can see it in the terminal as you get it from the tool, but where you want to see it is in the editor, because that's where it's going to be valuable to you. So this is another thing that I'm just not going to tell you about right now and build the dramatic tension. Performance. Now, I have to put this in because this is RubyConf. Some of you don't care about performance with good reason. Some of you are in situations where that's just totally not an issue. And if that's you, then you can just tell jokes on IRC or whatever, and I'll try to let you know when the slide is done. But a lot of times this is an issue, and a lot of people like to act like it's not, but this is something that you may need to measure. So here's how you do that. The problem here is that often it's so application specific that you're going to be diving into your profiler all the time. If you're lucky, you can just measure the, say, the example I like to use is, how long does it take for this certain request to complete? And just as total black box, how many milliseconds is it? And you might have requirements like this has to complete in 200 milliseconds or something. Great, okay. This is really easy, actually, to set up a simple black box response times performance testing framework. Julian Boot had a talk, I think it was Julian Boot, at RailsConf about it. Awesome. It's so simple. It's like 50 lines of code or something. So write your own. It's worth doing. You'll understand it better. And it's not a lot of work. The other thing you can do, if you don't have those specific requirements for response times, is to measure your test suite. And this is a lot more of a general, what's the health of my application metric than the other. But if you do measure this over time, you'll get a good feel for how it's doing, what impact your changes are having. And again here, you probably want to get notified of this daily. So the same idea as with the flog and heckle stuff. But you don't want to get stuck having to wait for the end of the day. Like you're working on a bit of code that you suspect has a pretty serious performance. You're taking a pretty serious performance hit for. You don't want to have to wait till midnight for the stuff to run. So make sure you can invoke it manually. And this should be really obvious to everyone who has any kind of impact on the performance of the project. They should all be on the list. But again, you should get this fed back when it's valuable. So if everything's okay, maybe decrease the frequency. But when things go wrong, you want like klaxons going off and emails going out. And you want to have two different ways of measuring that. One is if you have those hard fixed requirements, 200 milliseconds for this response. Any more is unacceptable. Then you have an absolute threshold. But you also want to have some kind of relative threshold where, if in the morning the code was responding in 150 milliseconds and now it's taking 199 milliseconds, you haven't broken that requirement, but you still want to know about it. So set up both of those levels. And that, as far as I think, that wraps it up for the things that almost every project or most projects are really concerned with. Your project might have unique concerns. That's probable. But these are the kind of things that work across the board. For your history, I think it's really valuable to have it around. So once you've got all this feedback, you might as well keep it and do stuff with it. So you can chart your personal growth. Right? This can be really encouraging, especially if you start seeing, we're seeing much smaller gaps in between the green bars on our test suite, right? That's cool. You want to see stuff like that, and you can use it to show off or point fingers too, if that's your thing. So, I know what you're thinking right now. You're like, this is really cool theoretically, and it just seems like a lot of work. I don't want to be jotting down performance metrics and all these things all the time. It's a lot of extra burden. So, right, we build stuff to handle this for us. That's how we do things around here. So, the tool that I'm going to be talking about is something I've just been working on myself for a month or so. It's called Augment, and that comes from the cybernetics background, where you have this idea of augmenting human intelligence and Vannevar Bush and all that stuff. It's great. My laptop's named after him. He's cool. So augment looks a lot like testunit.l, and it's available here. I'm going to be demoing. It's got pluggable architecture where you can have different backends that you swap in and out. So I've implemented a test unit backend using mini-unit that will take care of accuracy. But there's a whole lot more to do in terms of this, right? It needs to work with RSpec. It needs to work with flog. I'm working on the flog one. Performance metrics could get integrated into this. But it gathers these bits of metadata, really, about your code. And then it has pluggable front ends that allow you to output it and feed it back, depending on whatever your preferred environment is. I've got one for shell coloring and one for Emacs and one for HTML that I've written right now, but I've got a friend working on one for TextMate, and there's not much to it, to a front end. It's just highlighting and displaying messages. So it should be really easy to implement in your system of choice. That's not what I meant to click on. So I was going to demo this because that's what this slide says. So let me pull up the editor of choice here. Right, so you change directories into your project. And I'm just going to clear it out first. And then let's take a look at our test directory, right? Just one file in it. And then we run this test backend on that file. So we augment it. And that ran the tests, but was quiet about it because it was storing the results behind the scenes. So, oh, look, there's a new directory in there. Yes? Oh, yeah, sure thing. There we go. Is that better? Yes. Okay, good. I have poor eyesight, too, so I can relate. So just to review that, in case you guys are in the back with eyesight as bad as mine, we changed the project directory, cleared things out. There's nothing in there but this one file. We run the back end on it, and whoa, there's this metadata directory that exists now. So what do we do with that, right? Well, we can run this front end that the ANSI, uses ANSI color codes to output it in a way that the shell understands. Let's try that. Okay, the font size got bumped up a little too high here, but here's the file as it exists on disk, plus this, it's been augmented by this test backend, so it has some coloring in it. It's your basic test unit file, except, whoa, we misspelled equal. Oops. So that's colored yellow. Yellow is an indication of an error, and red is an indication of a failure. So the second test, nothing going on in there. The last test, we did something really stupid, so it's red, right? And that's your simple shell front end. I wrote this mostly just for testing purposes. Then let's take a look at what's in that directory that I showed you. And this is a JSON file, and that is really wrapped tight. Wow. But it's basically just a line for each layer, augmentation layer that you saw in the output. And I chose JSON because it's good interchange across the board. There's an Emacs mode for it. Any language can parse JSON, hopefully. So let's see. That's great, but who wants to spend all their time in the shell? Not me. So I'm opening up this same file in an Emacs buffer now for editing. There it is. I'm going to launch augment mode now, and you see it actually ran the tests in the background and made that. I'm going to get rid of the middle one because you can see them both on the screen. And I haven't saved, but I'm going to change this here to that and save the file. And, oh, the red went away. So you get instant feedback like that, and it just happens for you immediately like it should, right? It's right in your face. So that's the general idea. It's kind of embryonic right now. Just got this core of front ends and back ends, but if you're interested in feedback and making that happen in a better way, then you should, well, I have a slide about that. So, yeah. you've got a unique project, and I've got all these ideas that come from my background and what I find useful, but you need to do more than just apply, whatever the things in my slides have been. You need to think critically about what would be useful to you. So any decent editing environment, you can pull stuff like this off in. It's just a matter of making it happen. So we've read The Pragmatic Programmer, where he says you need to learn your editor and everything that it does, right? So that's good. That's a good starting point. But you need to learn not only what it does right now, but what it could do with a little jiggering, with a little help. Because it's not just this program that you use and you're an end user of. You really need to have this back and forth interaction with that. So yeah, make it happen. It's a lot of fun, especially if you get to write eLisp, because it's almost as fun as writing Ruby. It's great. Yeah, surprise me. Come up with whatever's important for you, what's useful on your project. I've been mostly talking about the editor, and that's probably the most important place to start. But getting feedback from your browser is just as important. I talked about auto test and how it watches the files on your system and runs the test for them. The GNOME browser called Epiphany actually does the same thing with files on the hard drive. It listens for I/O events on the disk, and it reloads any file that's been changed. Someone needs to take that and make it understand Rails routing system so it knows when to reload pages, and port it to Firefox and just do all this great stuff. Here's a little hint of how you would go about doing that. MozRepl makes it definitely doable and a lot of fun, actually. So your app has unique demands. Don't take my word for it. Just, start hacking, doing your thing. And if it fits into this Augment project, then patches, please. So there we go. That's my talk. I'd especially be interested in anyone's ideas about other metrics here that are important. I've listed the 4 that I covered, but maybe you've been on a project where you had something that I just never have thought of. And questions? Yes, over here.
Does Augment have a role in terms of the feedback you were talking about that would be more useful to get emailed to you on some sort of regular basis or based on thresholds?
Yeah, that's something that it will have. It's a month old right now. I've just been doing it in my spare time at Seattle.rb, so not yet, but that's definitely a planned goal of the project. Anybody else? Yes?
You talked about metrics and timing. Do you have ways to easily hook this up to things like RD libraries or graphs or whatever? Really viewing metrics is a big step. So
the question was, what about visualizing performance metrics? This should be hooked up to graphs. Absolutely. That's a great. You saw how the visuals were improved with testing, and that's totally just as important with performance metrics as well. Again, I've got these 2 dinky little front ends and back ends, so not a lot's there right now, but this is Ruby. We can write it quickly, and let's do that, right? You can be in charge of that. PDI. Anybody else? If we end early, we can come up and you can get a picture taken with the monkey. That could be a lot of fun.
We can touch a monkey?
Didn't say that. Okay. Great.